The world is used to Turkish drones being something small, inexpensive, and mass-produced. The Akinci has arrived to break that stereotype over its knee. It is a 6-ton flying cruiser that looks down on its predecessors as if they were children's model airplanes. Let's look at the facts. If the TB2 was a successful startup, then the Akinci is an aggressive corporation. Turkey has created a machine comparable to a fighter jet in terms of mass and wingspan, yet it doesn't require a flashy pilot in a mirrored helmet. That is the key spice. The Turks have stopped playing around with the cheap and cheerful concept. They have built an apparatus that carries cruise missiles and heavy bombs, ignoring the rules that say a drone must be small and inconspicuous. This is a defiant refusal of a supporting role. Now they decide for themselves how heavy their word in the sky will be, and that word weighs 1.5 tons of combat payload. This is a drone for those who aren't satisfied with just observing. The Akinci is built to dictate terms, staying in the stratosphere as long as it takes for the opponent's patience or equipment to run out. The Akinci is a tool for those who want to deliver strategic-level strikes without risking a pilot's career or the cost of a fighter jet. It is a machine designed for the systematic dismantling of enemy defenses in 24/7 mode. The primary mission of this aircraft is the isolation of the combat zone. While ordinary drones handle tactical reconnaissance, the Akinci goes after high-value targets, command posts, communication hubs, and fuel depots deep in the rear. It was designed as a carrier for heavy cruise missiles that previously only full-sized aircraft could lift. The Turks have bet on autonomous patrolling. The drone can wait for days for the moment the enemy's air defense blinks to instantly deliver a half-ton gift. This is pure pragmatism, replacing an expensive-to-operate attack aircraft with a platform that never tires and never asks for a vacation. Ultimately, its purpose is to turn war into a monotonous process of liquidating enemy resources, where strike decisions are made thousands of kilometers from the front line in perfectly sterile conditions. The Akinci features a 20-meter wingspan with an unnatural crank, making it look like a giant vulture. This isn't a design flourish, it's the only way to keep a 6-ton beast from plowing the concrete with its propellers during takeoff. The gull-wing shape allowed engineers to raise the engine mounting points higher while maintaining a low center of gravity for the airframe itself. This is critical for stability. When 1.5 tons of ammunition are hanging from the pylons, any buffeting in the thin air could send the drone into a tailspin. The wing's crank acts as a stabilizer, dampening oscillations and allowing the Akinci to maintain a perfect horizon even when launching heavy missiles from one side. This is pure brute force aerodynamics, where form is dictated by the weight of the missiles, not aesthetics. The result is a wing that forgives overloading and balance errors, turning the Akinci into a stable platform capable of hovering in one spot in the stratosphere for hours, regardless of turbulence. The Akinci is not assembled in old-school aircraft factories, but in high-tech incubators, where robots and carbon fiber have replaced aluminum and rivets. The entire fuselage of the Akinci is a layer cake of composite materials. Using carbon-reinforced plastic allows the airframe to be lightweight yet incredibly strong, which is critical for a 6-ton takeoff weight. Bayraktar has built a vertically integrated system. They don't just screw parts together, they manufacture key components themselves, from control systems to fuselage elements. This allows them to bypass any export restrictions or sanctions. Automation on the assembly lines minimizes human error. Every millimeter of a seam and every bonding point is controlled by electronics, ensuring the perfect geometry required for stable flight in the stratosphere. This approach turns Akinci production into an endless printer. While competitors spend years coordinating component deliveries, Turkey simply scales its workshops, filling the sky with machines built to a single digital standard. The Akinci runs on hardware that doesn't fear sanctions. Ukrainian turboprop engines provide the necessary power, while 5 onboard computers turn this glider into a thinking organism. The propulsion system is the foundation. Most often, it is powered by 2 AI-45OT engines with 450 horsepower each. These are simple, sturdy workhorses that allow the 6-ton giant to gain altitude confidently. But the magic is inside. Control is handled by a triple redundant system. If one AI head fails, the other two take over the course. The drone constantly analyzes data from hundreds of sensors, self-corrects its flight in high winds, and can take off and land autonomously without operator intervention. This is not a remote-controlled model. It is a robot that receives a general mission and decides for itself how to execute it, using satellite links for global reach. The result is a symbiosis of raw mechanics and digital intelligence. The engines pull it upward, while the AI ensures that every drop of fuel and every second in the air brings the drone to its target with mathematical precision. The Akinci climbs to 12 to 13 kilometers, not for the view, but to become unreachable for most short and medium-range air defense systems. An operational ceiling of 40,000 feet is a strategic trump card. At this height, the drone is outside the engagement envelope of man-portable air defense systems, man-pads, and many mobile defense systems. Meanwhile, it can stay in the air for up to 25 hours at a time. This allows it to do more than just go on a raid. It can literally move in over the operation area. A flight range of 7,500 kilometers turns it into a global reach tool. Taking off from a base deep inland, it can cross borders, engage targets, and return without ever needing to stop at forward refueling airfields. This is the exploitation of physics for the sake of total tactical impunity. The Akinci wouldn't have been born so quickly if Western countries hadn't tried to teach Turkey a lesson with sanctions. The Akinci project was a direct response to Turkey's expulsion from the F-35 fifth-generation fighter program and difficulties in purchasing American Reapers. Bayraktar's leadership bet on import substitution in its most aggressive form. Instead of waiting years for US congressional approval to buy components, the Turks began building their own ecosystem. They joined forces with Ukrainian engine manufacturers and created their own optoelectronic systems and software. The first flight in December 2019 was the moment of truth. Turkey showed it could build a heavy unmanned platform comparable to global counterparts using its own engineering schools and flexible international alliances. The Akinci is the first drone that stopped nipping and started truly killing. With a 1.5-ton payload capacity, it doesn't just carry missiles, it replaces an entire ammunition depot hovering over the enemy's head. It has 9 hardpoints, and these are not decorative pylons for light rockets. The Akinci is designed for heavy calibers that were previously the sole prerogative of F-16S or Su-24S. The ace up its sleeve is the SOM family of cruise missiles, capable of flying 250 kilometers. This allows the drone to destroy strategic targets without even approaching the air defense zone. For area work or hardened bunkers, it uses guided bombs from the Mk-81, 82, and 83 series, with laser or GPS guidance. The entire range of weaponry is purely Turkish-developed, MAM-L, MAM-C, Sirit, making it autonomous not only technically but logistically. This firepower turns the Akinci into a universal Swiss Army knife of war. It can surgically take out a single SUV or bring down an entire bridge, matching the caliber to the budget and importance of the target mid-flight. The Akinci is the first serial UAV in history to stop being prey for fighters and start hunting them itself. Technically, this is achieved through the integration of Turkish air-to-air missiles, Gökdoğan, short range, and Bozdoğan, medium range. Thanks to an onboard AESA, active electronically scanned array radar, the drone sees targets at immense distances and can guide missiles in automatic mode. This changes the very logic of UAV deployment. Now the Akinci can provide cover for lighter drones or intercept enemy helicopters and reconnaissance planes. It doesn't enter a maneuvering dogfight, but works as a high-altitude sniper, launching a fire-and-forget missile before the enemy even visually detects the threat. The integration of air-to-air combat capabilities makes the Akinci a harbinger of an era where manned aircraft will become too slow and vulnerable compared to AI platforms that know neither fear nor G-force limits. The heart of the Akinci is not its engine, but its AESA, active electronically scanned array radar, which transforms the drone from a blind executor into a full-fledged combat management center. This is fifth-generation fighter technology packed into a UAV airframe. Having an AESA radar allows the Akinci to see the battlefield in ultra-high resolution, ignoring weather conditions and cloud cover. It is capable of tracking dozens of ground and air targets simultaneously, transmitting data to other drones or artillery batteries. In addition to the radar, it carries the Aselsan CATS multi-purpose targeting system, which paints targets with laser surgical precision. But most important is the electronic suite designed to counter electronic warfare, EW. The drone is packed with countermeasure systems that filter out interference and maintain satellite links even under active enemy jamming. This turns it into an invulnerable information hub. Ultimately, the Akinci sees everything while remaining transparent to many detection systems. It is the first to find the target, the first to make a decision, and the first to strike, leaving the enemy in the role of an extra in a digital war. The Akinci isn't gathering dust at exhibitions. It has become Turkey's primary argument in local conflicts, turning real combat operations into a marketing showcase for its defense industry. This is a drone writing the history of warfare here and now, confirming its status as death from the stratosphere in practice. The aircraft received its baptism by fire during operations in northern Iraq and Syria, where it was used for the precision liquidation of militant leaders. There, it demonstrated its key feature, the ability to loiter over a target for hours and strike exactly when the objective is most vulnerable. Unlike its younger brother, the TB2, the Akinci targeted reinforced concrete bunkers that ordinary drones would only scratch. Its participation in these operations proved that Turkey had gained a tool allowing for deep raids without a declaration of full-scale war. Every flight generates terabytes of data that are immediately sent to engineers to refine the software in real time. As a result, the Akinci has become a symbol of new Turkish diplomacy. It doesn't just fly, it shifts spheres of influence, forcing neighbors to reckon with whoever controls the skies over the entire region from a single control panel. The Akinci is the fruit of a technological alliance. Without Ukrainian turboprop engines, this 6-ton vulture simply wouldn't be able to get off the ground and claim its niche in the stratosphere. The Akinci's connection to Ukraine goes beyond merely purchasing AI-45OT engines from Ivchenko Progress for the base versions. It is a full-scale industrial integration. Despite ongoing hostilities, Kyiv and Ankara completed a factory near Kyiv, which in 2026 is already reaching its design capacity of 120 drones per year. The Turkish side invested approximately $100 million in localizing production, while Ukrainian engineers underwent training in Istanbul to assemble and maintain these machines. Even after missile strikes on the factory infrastructure in 2025, Bayraktar reaffirmed its commitment to restoration, stating that hardware can be rebuilt, but partnerships cannot. For Ukraine, this is a path to becoming a regional hub for the maintenance and production of heavy UAVs. For Turkey, it is a guarantee of uninterrupted supplies of key components. In the end, the Ukrainian trail has transformed the Akinci from a purely Turkish project into an international asset. While engines from Zaporizhzhia pull the machine upward, the joint workshops near Kyiv make its production invulnerable to external political pressure.